So we're going to be doing the equation of a particle with a charge of negative 4.3 and a mass of 3.6 times 10 to the negative 6 is released from rest at point A and accelerates towards point B, arriving with a speed of 22 meters per second. The only force acting on the particle is the electric force. We're going to be finding the potential difference between A and B. So the conservation of energy gives us that the kinetic energy plus the potential energy equals 0. This can be rewritten as 1/2 of the mass times the final velocity squared minus 1/2 of the mass times the initial velocity squared plus the charge times the difference in the potential. So we know that the mass is 3.6 times 10 to the negative 6 kilograms. We know that the charge is negative 4.3. We know that the final velocity or speed was 22 meters per second and the initial speed was 0 meters per second. So if we rearrange this is going to equal 0. If we rearrange this, we can get this isolated by subtracting this side onto this side, and because we know that the initial speed is 0, this cancels out, so we get Q is equal to negative 1/2, and then we can move this by dividing both sides by Q. We get VB minus CA is equal to negative 1, just negative NV over 2 times Q. And then we can just plug in our known values here. We know the mass, we know the final speed, and we know the charge. So we get that the potential difference is going to equal And then we also have to remember to convert this over to coulombs. So it's going to be negative 4.3 times 10 to the negative 6. And then if you plug that into the calculator, you get about 202.6, and that's going to have the units of volts. And that is going to be the potential difference, and it is going to be positive.